So this is our very last example in section 3.5, and goal 2, we're going to look this time at logarithmic functions and how they can model and solve real-life problems. So here's a little bit of information. On the Richter scale, the magnitude, or R, of an earthquake of intensity I is given by this function. R equals the log of I divided by I sub 0, where I sub 0 equals 1. This is the minimum intensity when we used for comparison. So R represents the magnitude of an earthquake, and we can calculate that magnitude with the equation log of the intensity divided by the initial intensity, which is represented by the number 1. Intensity is a way to measure the wave of energy of an earthquake. So in this example, in 2009, Crete, Greece experienced an earthquake that measured 6.4 on the Richter scale. Also, in 2009, the north coast of Indonesia experienced an earthquake that measured 7.6 on the Richter scale. So obviously we know that the Indonesian earthquake was more intense than the not Greece, but the earthquake in Greece. But we want to find the intensity of each earthquake and then compare those two intensities to one another. So using this model, let's first look at Greece. So R equals the log of the intensity divided by the initial intensity. All right, so we were told that Greece experienced an earthquake that measured 6.4 on the Richter scale. We're told that R is the magnitude of an equation on the Richter scale. So 6.4 is equal to the log of the intensity divided by 1. We don't have to put that over 1. So how would we solve this equation for I? Well, I recognize that this is a common logarithm, so we can put base 10 here and change this to exponential form. So I is equal to 10 raised to the 6.4 power, and I'm going to put a sub g here to remind me that this is the intensity of the earthquake in Greece. Now let's compare that to the earthquake in Indonesia. Their earthquake measured 7.6 on the Richter scale. Again, we know this is base 10, and the intensity I is divided by I sub 0, which is 1. So when we change to exponential form, we have 10 to the 7.6 power equals I, and I'll put a sub I to remind us that this is the intensity for Indonesia. So if we're going to compare the two intensities, we can use a ratio. Remember that a ratio is the comparison of two numbers, and I'll compare this in the order of Indonesia compared to Greece. And I'm choosing Indonesia compared to Greece because Indonesia was the higher power. So 10 to the 7.6 power divided by 10 to the 6.4 power. We know when we divide like bases, we subtract exponents. 7.6 minus 6.4 is 1.2. All right, well, let's see what 10 raised to the 1.2 power is equivalent to. And that's approximately, so that's 15.85. Okay, so we found the intensity of each earthquake, and then when we compare those, we could say that the Richter scale had an increase of 1.2 the units on the Richter scale, and the earthquake in Indonesia was almost 16 times greater than the earthquake in Greece. So we would say that there was an increase of 1.2 units on the Richter scale, and the intensity of the earthquake in Indonesia was 16 times greater than the earthquake in Greece. Well, I hope that this helped give you an idea of how exponential and logarithmic functions are actually useful in real-world scenarios.